Peter Clay has more than 25 years of experience in cybersecurity disciplines to include. He has served a number of U.S. federal entities in diverse industries including defense, numismatics, product development, manufacturing, and the global financial industry. In working with those organizations, Mr. Clay has served as a trusted advisor of executives, boards, and government leaders globally. As a consultant, Mr. Clay enabled several unique security solutions to include the Department of Defense Common Access Card, Department of Homeland Security TWIC system, securing production for the U.S. Mint, security testing for Homeland Security, and the Bureau of Engraving and Printing. In addition to his consulting roles, Mr. Clay has held several security leadership roles to include Chief Information Security Officer for large global companies and designed 19 global operations centers.
Introduce Peter Clay. He has more than 25 years of experience in cybersecurity. He has served a number of U.S. federal entities in diverse industries, including defense. And currently, he is a Chief Information Security Officer at Aireon. And Aireon is the pioneer of space-based automatic dependent surveillance broadcast data for the aviation industry. And I look forward to your presentation, Pete. The floor is yours.
Thank you so much. Let me go ahead and share the presentation. Aireon today is very much focused. We are delivering services. We are a space-based air traffic control system. Every commercial aircraft that's in the air as we speak is being tracked by Aireon. Aireon, yep.
Sorry to interrupt you. Could you make it like a full screen at the moment, or so we can
better? Is
better?
That better?
No. Yes, now it's better. Yes, thank you.
Okay. So Aireon works with the Iridium satellite services. Every commercial aircraft that's flying today, about 13,000 targets at the moment, communicates with the spacecraft, the satellites, and allows us to understand where those aircraft are and the performance of the aircraft, what's going on with them, what the speed is, their location, altitude, and some critical system information. We take that information, the travel time from the aircraft to the spacecraft to the downlink, and then using terrestrial systems, we push it out to about 60% of the world's air traffic control functions. That loop takes about 7 seconds. And so when we started thinking about the issues around quantum security, we were in the position to ask a lot of questions. We are actually certified by the European Union as an air navigation service provider, same as Eurocontrol or any of the country-based ANSPs. And so we started talking to a lot of different folks to really understand what was going on with quantum and the risks for quantum security, because ADSB, the information we base our service on, there's really nothing secret about it. You can set up a Raspberry Pi on your desktop right now and receive ADSB information from aircraft within range of the Raspberry Pi. So secrecy isn't our concern. But what is a concern is the integrity of that information from the time it's transmitted to the time it's delivered to our customers. And for that, we use cryptography. We also use cryptography to ensure that all of the components that are speaking to each other are authenticated via the cryptographic algorithms. We heard a lot of different estimates in terms of when, quote, Q day, when quantum cryptography would be able to break current asymmetric cryptography. We heard timeframes that range from it would take until 15 years from now to it may have happened about 1.5 years ago, depending on where you live in the world and which nation state might want your information. So we took away a couple of things that we really started to understand from that. And what this first slide really talks about is no cryptography system ever survives the test of time. And we know a couple of things about quantum cryptography that we've applied to our project within Aireon to manage it, because it's a little bit difficult once you put a spacecraft in orbit to go up and fix your crypto keys. So number one, when an opponent breaks a cryptography system, they don't announce it to the world. In fact, they keep it pretty secret. In all of these cases, you can see there was a range between 1 and 20 years before it became common knowledge that the cryptography systems had been exposed or had been broken. What precedes those breaks every single time is a catch and decrypt. We're just going to take in as much information as we can possibly store. We're going to capture as much of it and store it for as long as we possibly can, based on the assumption that at some point we will be able to break the encryption that's protecting it. Number two, we started really thinking about how our cryptography could be possibly exposed and where we needed to look for it. A lot of the industry conversation that you will see today, and as somebody who's actually had to run this project on a space-based system, you have to start really thinking about where you consume cryptography and the types of cryptography that you consume it in. This has to be a risk-based decision point. You're not going to be able to replace it everywhere constantly, but our event horizon right now for the systems that we're planning goes out 20 years. So we know that we have to build in quantum agile or agile cryptography, because the odds of NIST or any other regulatory body getting it perfectly right the first time are pretty low. So we know we're going to have to rotate both the keys and the methodology of encryption possibly a couple of times to protect our systems. We also had to really understand how we were using cryptography and where we were using it. We found it in our external systems, kind of looking from the outside in. We found it on our internal systems, not just securing data in motion, but data at rest, data authentication, internal cloud communications, etc. We found it embedded within IT assets, not just our components or hardware that sit on the spacecraft, but also everyday things such as laptops, etc. We found it buried in databases, both our software as a service databases for business applications, as well as our custom built information. And then primarily we found them in code as well. So the first thing that we're really seeing that organizations are doing, and one of the reasons we're doing talks like this, is they're missing where a lot of their cryptography lives because nobody has the good inventories of it. And those have become very, very challenging to figure out. The US federal government just went through a round of cryptography inventory, and the internal conversation that's happened so far is fundamentally those did not even come close to hitting the mark. So they're probably going to have to be reperformed over time. The other conversation we heard, and we actually got into a very interesting conversation with John Kindervag, because I started off from a position of zero trust. It's very much all of this effort going into zero trust right now for all of these different systems. Zero trust is very much at risk because it's so dependent upon cryptography, both symmetric and asymmetric key cryptography. In talking with John, one of the points, because people having conversations right now about quantum cryptography as a CISO, is a lot of times CISOs have to think very tactically. What didn't kill me yesterday that I need to clean up? What do I need to deal with today to manage and be effective? And what do I have to manage for tomorrow to make sure that a 0-day or a problem doesn't get me? So as a CISO today, a lot of my time is spent thinking about those 72 hours. It is absolutely critical, if you're going to have quantum conversations with customers, that you're able to attach to something that they are thinking about in those 72 hours. Because otherwise, what's going to happen is you're going to get embedded cryptography living in their systems, and suddenly there will be a decisive break or a decisive announcement that they are exposed, and they will have a greater period of exposure than they otherwise would have. Prior planning is critical. Zero trust are strategies that are being implemented today. And if you start to think about how the impact of quantum cryptography impacts zero trust and start to adjust your zero trust programs for that, they become a very effective framework for protecting against the failure of cryptography. Encryption will have to change everywhere. As a CISO, I have to make decisions about how fast to change it and where to change it. But make no mistake, both your asymmetric and your symmetric key cryptography will have to change. It's only a matter of when. So if you take the first statement that I really made here, that sometime the mean over under right now for when it will be widespread there will be widespread capabilities to break the current cryptography systems is somewhere between 18 months and 3 years, depending upon where you live in the world. So that really becomes the fundamental strategy and planning point for how are you going to protect your information, what are you going to do, and what does that mean to your existing systems. Your post-quantum journey is well defined at this point. You have to identify where it sits. Identifying it is absolutely the first step in getting well in this particular space. That means doing a risk assessment to understand not only where the cryptography itself sits, doing the cryptography bill of materials and building those things out, but also doing a risk assessment to understand how that cryptography is going to impact your company, your organization, and your system. When you have that kind of information available to you and you have an organization that will engage with that, they're going to start getting better fairly quickly. Once you've completed that assessment, establishing a roadmap to not only prevent the situation from getting worse, setting the new standards and processes to ensure that the cryptography we buy today will be post-quantum compliant, but also understanding that the stuff that you build and your internal systems also have to migrate over time. Some of that you can do by simply retiring systems at end of life, depending upon your tolerance for risk. Some of it you're going to have to think about on a fairly emergent basis. So now you have to think about your entire environment, right? Because very few organizations now are just totally on premises. You have to think about cloud and start to have all of those conversations. You also have to think about your third-party suppliers. The greatest hacks of truly classified sensitive information have seldom come from either government entities or the primary contractors. They've come from contractors that are second, third, fourth, and fifth tier contractors. They were able to use the cryptography that they were able to capture. They were able to use that to authenticate themselves back into the main systems. So understanding where your zero trust controls need to be placed and what you're doing, and then start to deploy your technology. Right now, Aireon is sitting at basically the third step. We have a pretty good handle. We've done our initial inventory. We've put in place the things that prevent us from getting worse. And we understand what we're having to do to build out the next generation of things effectively. And now we're going through and starting to migrate our existing trouble spots into more secure forms of cryptography. That remediation process for us will take approximately 6 years. It will be something that we iterate and reiterate and iterate and reiterate. So part of the thinking around this stuff that's so important is to make sure that you don't just think I can do an inventory one time and be done with it, because you will be amazed at how often new forms of cryptography pop up because somebody built something over here, somebody did something over here. Maybe it's test, maybe it's just a piece, but at the end of the day, it will pop up and you're going to have to address it. So there's a training component to this as well that is vitally important. You have to start talking to the developers. You have to start talking to the purchasing folks. You have to start talking to the supply chain. Finally, monitoring against the standards is how you make sure that all of this works. And that feedback loop has to go back from monitor, back through identify, assess, and build controls and remediate. So it becomes a continuous process, and continuous journey that you have to run through. Our approach today and what we're operating today is we run external scans on all of our external interfaces once an hour, so that we understand literally hour to hour how our posture and how our information changes, how our cryptography approaches may change. We tie that in with threat intelligence. So if this starts to sound like a SOC approach, you're right. This ties directly into our SOC, because this information feeds directly into our threat intelligence service as well as our security operations center. So the cryptography function, as we're monitoring and measuring it hour to hour, if we have changes, that goes into our incident response system that's driven by our SOC. We do the same process with internal scanning. These scans are very, very lightweight. You don't have to do super aggressive scanning to get the information that you need. You just need to be able to aggregate it and pull it back together in a way that makes sense. But we do continuous verification on, did the fix that we implement, is that showing up correctly, which validates the tools, as well as did it actually fix the problem? And then finally, we maintain our consistent inventory. So what we've done over the last couple of months is we've moved through the initial parts of the process, the identify, assess, and control. We've now instituted this as part of our vulnerability management and security operations function. And we do this on a continuous basis. We're currently working with our next generation systems, the next generation of spacecraft that we're going to be consuming that launch in about 8 years. We're going to be working with some of the new products that we're developing, as well as working with the aircraft manufacturers to ensure that both they're aware and that we're in sync with the changes that they're proposing. The takeaway from this part of the conversation is, as a chief information security officer, I understand that the 3-day thinking impact, yesterday, today, and tomorrow. But this is a critical process and critical approach that's going to dramatically change their life over time. And the worst position you can be in as a CISO is to have to go to those that you report to and explain to them why exactly you have a 2 or 3 year exposure problem that could have been foreseen and could have been mitigated long before you got to that point. Are there any questions about what I've shared, kind of what the experience has been and how we've done this?
For the remediation, hello? Am I audible?
Yep. Yes.
Yeah. So when you were planning for the migration, the identification phase how was it executed? Like, did you go through the implementations, the code exactly, or like, was it a higher level identification? Like, how did the identification phase look like? Because did we go through the code implementations line by line? Because we have to actually migrate the crypto assets, right? So how did the migration phase look and the identification phase initially look like?
So once we started to really understand the challenges that we had, and that in a lot of the information that was publicly available was incorrect, and the initial inventories, at least done in the US, were not using a methodology that was either repeatable or useful. We developed this implementation, or this detection process, using available tools, and then aggregated all of those tools into a single reporting system. So we have a tool now that sits outside and looks at our systems, scans our systems once an hour for that available information. So we're looking at the as-built environment as it's sitting, our attack surface, if you will. We're looking at the internal systems, again, once an hour, using a different set of tools that's able to go all the way down to the registry level, because that's where we found we had to make those efforts and approaches to make this be effective. We certainly worked with GitHub initially, and now we have there are a couple of very interesting tools that have been developed that are currently available that allow us to look at code on an ongoing basis. And we've upped our game around code to now we literally, it is resident with the developers. As they're developing code, we're able to scan it and quantify it and qualify it as they're developing it. We also started the effort with our third party. We also started the effort with our third party suppliers. Both those we supply information to, because again, we're responsible for providing air traffic management for 60% of the world's air traffic currently. Starting those conversations, we found a really broad variety of preparation in CISO to CISO conversations. Some of them were well down the program. We were able to compare notes. We were able to understand what was going on, and we were able to share best practices that we had found successful. Others of them had not started on the process, had not started thinking on it, and were not interested in engaging. That's up to them. That's fine. So our approach, we believe, was very holistic, but we look at this, Mahima, in a with a very critical eye to make sure that we understand what's going on, because for our business, which is dependent upon the integrity and authentication parts of the triad, this is something we simply cannot get wrong. Did that answer your question?
Yeah, so it was mostly code analysis.
No, code analysis was one of the 5 things, and it took about 15% of the overall effort.
Okay, so the remaining were process evaluation, context evaluation, like what else did we identify to actually filter down the assets that is being used? Because assets comes down to any of the crypto algorithms that we are using, right? Or the process that is coming around that. So one is code analysis. What other methodology do we have?
So we custom built tools to do active scanning that would be familiar with the tools that we use would be familiar with virtually anyone who's running a SOC or running a moderately mature cybersecurity program. We did build out custom signatures to put into those tools to make sure they were as efficient as possible. And then we use those, we use that and update and upgrade those on an ongoing basis.
Okay, so that is specific to your organization. It cannot be applied for a different organization.
Go ahead. There are organizations now that we have shared this information with that are beginning to offer these things commercially and for purchase.
Okay. Thank you.
Okay, I would like to interrupt that conversation. Sorry, thank you, Mahima, for all your questions. Maybe we can take one more question from the chat. There's also a lot of them. So what about your opinion about QKD? Any advice? Are you going to be expanding for your systems to it, or that's from Bob Dirks?
We have adopted a strategy of being crypto agile. QKD, we understand it. I will quote Tahir Al-Gamal, commonly known as the father of SSL TLS. Crypto agility is the absolute necessity here. The amount of testing and the amount of approval and just simply the amount of testing for me to be able to trust any algorithm goes beyond what NIST and MITRE have been able to do to date. And given remember, there's also vast unknowns around quantum itself. We don't know that QKD will stand up. We don't know. But what we do know is we're going to have to change the algorithms and change the processes probably repeatedly. And so we believe that our safety is going to be found in using the best possible cryptography at the time, whether that's asymmetric or symmetric key or some combination thereof. And those are the solutions that we're implementing.
Thank you. Then there is only the last short question would be about once an hour from Mike Loginov. Why so slow as attacker? That's for the attacker is an opportunity. Why only once an hour you do the scans?
So Mike, we do operate the SOC in real time. We have other tools that are literally monitoring packet by packet. We felt that the once an hour to do cryptography discovery was at the upper end of what we needed to be able to accomplish, and gave us enough fidelity of the services and capabilities to gave us enough fidelity that we could have confidence that we didn't have a significant exposure.
Okay, thank you, Pete. Thank you, everyone, for the questions.